Hi, my name is Stuart Jones. I will be demonstrating the ECE 461 home alarm system. Alright, so as you can see, we're in Maine now. Currently I'm using driver labor 2200008. So the home alarm system in the broad aspect is a system that is designed to take in a value or take in various values and determine whether you are having a fire, somebody breaking your house, or somebody's just trying to come into your house and they want to ring the doorbell. So to begin with, we're going to stop our watchdog timer. Now, this line is commented out for the video's sake. It's only here to show that basically that I tried this to begin with, and I have chosen other ways because it'll optimize the code better, the power efficiency to be more exact. So what init all ports does is sets every port pin to GPIO. The ULP advisor said that to save power I needed to do it, so I tried it, and well, after reading the forums, I found out that it has the potential to brick your phone if you use this function, if you set port J as GPIO output. So that line was commented out, and I tried it with everything else included in the code, setting all the other ports. And I found, upon using energy trace and also using the sleep function at the bottom, or sorry, without using the sleep function at the bottom, that I had extremely high power usage compared to when I commented this out and left all the unused ports in their default state. And by using the sleep function, I had about a 55% increase in efficiency and less power loss. So as you can see, we do our initial setup. We make sure the buzzer is going to be off in case something happened where it got saved in a state where it was on before it was turned off. It shouldn't do it, but during the time of debugging, it has occasionally come on. So it's just a safety protocol. We're also going to activate the green LED to show that it is in our that the burglar alarm is in its disarm state. And we're going to initialize everything from the ports we're using, our clocks, the I2C sensor, both the switches on the MK2 booster pack. We initialize timer 32 and use both its functions of timer 0 and timer 1. Timer 0, as you can see, is going to be a half-second timer, a 500 millisecond. And timer 1 will be a 300 millisecond. Timer 8 is going to be our PWM timer. It will be our timer that's going to be used for the buzzer. Scrolling down, we establish interrupts and fall into the while loop. So the way that this works is this lux sampler value is increased through timer 0. So when it's equal to 2, we know that 1 second has passed, and in order to save a little bit more power, I chose to only poll for this, only try to get the lux value right here by, or every 1 second. Lux is light, so the brightness of a light. So a brighter light means that you have the potential that you have a fire. So what I do is I call the function sorry about that. Called the function in one of the given driver libraries for the labs that grabs the value for me. I compare the value to my threshold, which is 500, and this threshold is going to currently eliminate just ambient light that's in the house. Now, back to this 1 second. It's currently at 1 second, so in case, say this was implemented in the actual house and people were taking pictures, well, the camera flash is not going to last 1 second, and therefore it would not trigger the alarm. If tripped, or if the lux value does go past the threshold, however, the fire alarm is going to be tripped. Falling into the next task to be checked in the static scheduling, we see that we have buttons. We're going to check for button 2, and it's initially going to be in this state right here, and well, not technically in the state because button true, it's not equal to true, but it's going to simulate this state because the LED is going to be on and it's the disarmed state. upon pressing button 2, we will fall into here. We're going to initiate. We're going to turn the LED red to show that the burglar alarm is now active. It's going to initialize our ADC. Our ADC will only be on while the burglar alarm is active. If we press button 2 again, it'll go into this statement, and will actually make sure the buzzer is disabled if it was on, if the burglar alarm was tripped, and then it will turn the ADC off and turn the green LED back on, showing that the burglar system has been deactivated. Alright, so this next if statement is going to show that if the burglar was, if the ADC value, which is over right here, our ADC is initialized. We have our just simple functions of initialize it, so we can call that in our actual if statement. The initialization, the interrupt initialization and disable of the ADC, and our ADC handler is right here. So the process of what happens for tripping the alarm to set off this if statement. A loud noise occurs, and when a loud noise breaks our ADC high threshold, it'll trigger this service routine. Upon triggering the service routine, we know that we will get the value for our ADC, or from our ADC, and save it. We're going to check to make sure that neither button has set off the ADC, and if so, we're going to subtract a value that will hopefully prevent the burglar alarm from going off. If it's still high enough, then it means that somebody has actually hit the alarm system instead of just pressing the button. And the noise, if the noise barrier has broken the intruder threshold, and then we know that somebody's trying to break in, and we will flip our flag to true. At this point, we're going to exit the routine and come back here, and that's when this is true, when burglar break-in becomes true, and this will set off the alarm immediately. Upon setting off the alarm, we will fall into our burglar alarm, where we turn our buzzer back on. We set our duty cycle to a lower frequency. Let's see if I can pull him up for you so you can see it. The lower frequency is currently 100 hertz. Let's see if I can find back where I was. Okay, so after that, after the burglar alarm goes, it'll swap back and forth and to simulate a louder and a quieter noise in a faster rate, simulating a burglar alarm and hopefully warding off the intruder. If button 1 gets pressed, we ring our doorbell, and the doorbell gets rung. If the doorbell is rung, it will, let's see if I can find him, there he is. So the doorbell is a simple 2-second doorbell. It'll play a higher tone, and for a total of 1 second, and then after that second it'll play a lower tone. The doorbell also included in his functions, he actually includes the functions that turn the buzzer on and the buzzer off. Alright, so let's go back to main now that we have gone back. Upon finishing up with this iteration of the loop, we will go back to sleep and wait till another interrupt gets us. Now, say if the fire alarm did decide that it wanted to go off this time, say somebody did shine a bright light and it turned that the lux value got too bright, we are simply going to go and do the basic same principles as the burglar alarm, except the burglar alarm can be disabled. The fire alarm, however, will not be disabled and will have to be turned off upon a system reset. Alright, now we're just going to look at a couple functions. So, let's see, what do you want to look at? Alright, well, here's the LEDs. It's just simply configuring the port pins to go on or off of the red or the green LED. The macros we had to use during the process of building this file. or of this program. I've already shown you the ADC. Here's our I2C sensor, the initialization. Now, these use the driver libraries that were given in another project from the Project Explorer. Here we have initialized the timers. The watchdog is set to go off after 2 minutes and about 2 minutes and 51 seconds. Here we have our ports. Now our ports, these are the used ports. They are not initializing of every single one. They only work initialize button 1, 2, the buzzer, our RGB LED on the MK2 booster pack. It initializes our ADC, and we have our light sensor that initializes for our fire alarm. Oops. Here we have initialized our clocks. And our buttons. This is just a simple initialization using the driver libraries to initialize button 1 and 2. And just a list of all the functions that I've made. Alright, so now we're going to discuss the memory allocation. It's a static implementation measurement. Using all the techniques given from the by Code Composer, and just known techniques that I've done, I've been able to bring the flash memory down from, my original code was about 7.9K in the flash, still roughly 594 in the SRAM, but I was able to bring this down by implementing the map. By putting this underscore, or putting this in front of all of the driver libraries, it brought it down about 2K, which is good. So a precompile optimization option that I used, I went up to Project. I decided to I went to Properties, and I chose, because I have a lot of memory left, to use the speed size trade-off. I brought it all the way to 5 to make it as fast as it could be, and decided to make the entire program as the most optimized I can make it. Alright, now we're going to go into the debug state. Once again, the board is plugged up, so let's enter debug. Alright, now while we're waiting for it to load up here, I'm going to talk about what I'm about to do. I'm about to load up the energy tracer up here and show just what turning off init ports and initializing sleep down at the bottom would allow you to do. So let's go ahead and load up the energy tracer. It's down here at the bottom. We'll go to power. Right down here. And I'm going to full screen this real quick so it'll be easier to see on the camera. Now I'm going to start the program. And currently the energy tracer is recording about 47.1 milliwatts being used. Now let me go back down real quick. That implementing this sleep and initializing the ports allows this. If I had initialized all the ports as GPIO as suggested by ULP, it would have in turn brought it up to roughly 85 to 89%. So I have saved about 55% just in testing on the different cases of what I can try to do. The sleep, once again, puts it to sleep at the end of the at the end of the while loop and waits for interrupt. Alright, now once again this is plugged up, and so I'm going to cancel the debug session because my board has an issue with temperature, and any other way from doing this can sometimes cause an issue when it comes to actually plugging and using it. So, once again, try not to touch it because, well, it likes to mess up a lot. What I'm going to do, you see how right now it's in the disarm state. We have now initialized the burglar alarm. Now, just to show that the burglar alarm doesn't go off with the doorbell, there's the doorbell, and here's the burglar alarm. Now we're going to turn the burglar alarm off. Right? So now we have shown the burglar alarm. We have the doorbell, which is, well, it sounds kind of like a doorbell. Only thing left to display on this project is to start a fire. So I'm using this flashlight. Now remember, the board itself is going to wait about 1 second so that in case somebody's taking a picture, it's not going to set off. So here we go. And there we go. We started a fire. Now in order to turn it off, I'm going to show you we cannot press any button. The fire alarm is going off telling you to get out of the house or disarm the system. So the only way to disarm it is by system reset. Let's go ahead and get ready to turn it off. So system reset is this little button right here. So let's turn them off. And now upon system reset, it's back still in the disarm state. And that's the video. Thank you for watching.